Hi everyone, welcome. Here are the big takeaways from this Chapter 3 called 3Claims, 4Validities. Now this week we continue on that same theme of don't believe everything you read when reading research articles. The healthy skeptic is the scholar who always seeks evidence to support claims about scientific truth instead of blindly accepting someone's assertions as facts, no matter how authoritative the author may seem. We want to develop the skills to distinguish between valid claims and weaker claims in scientific research presented to us. Now, first big takeaway from this chapter. In this lesson, you're asked first to read that short article called on scientific inference. Now, this is a succinct review of all our own assumptions that we bring to reading research articles. We assume no bias by the author in types of data collected, included that the author showed all data findings, not just the ones that agree with her original research question, right? We assume the data presented are accurate. We assume the data were analyzed properly with regard to statistical analyses. Note that most of these concerns are resolved for us by a peer review, the process whereby the author first submits a research article to experts for review and critique, then only later is it finally published. Peer review is a mark of quality, and we mostly want to use peer-reviewed research in your professional future. Big takeaway number 2 in this chapter, the threshold for proving cause and effect relationships is very high. Cause and effect relationships are really important in research, guys. Meaning, to prove cause and effect in psychological research, it's very difficult, and we must meet specific standards. First, be sure to review the PowerPoint slides at the end of the previous chapter that introduced experimental research versus correlational research. An experiment is the only tool in psychological research for demonstrating a cause and effect relationship between two variables. And experiments have very specific rules for what constitutes an experiment. Anything else is not an experiment. Correlational research, on the other hand, only discovers relationships between variables, that is, that's two events that co-occur, not that one likely caused the other. Only an experiment can prove cause. Correlational research is very common in psychology for studying topics where we simply cannot conduct a true experiment. So spend time with familiarizing yourself with the important jargon and vocabulary at the start of this chapter's lecture notes. Cause and effect, independent variable, dependent variable, extraneous variables, as we'll start to use this language soon and regularly throughout the experiment. This is the language of experimental research, correlational research. You want to learn that language. Second, let's talk about proving cause and effect relationships. Again, this can be very difficult. The threshold can be very high. Science moves forward because researchers discover cause and effect relationships that help us understand and predict human behavior out in the real world. For example, discovering that social support can decrease psychological distress. Cause, social support. Effect, psychological distress. Social support can decrease psychological distress. This showed us that various forms of social support can help a person cope with even severe difficulties. So this led clinical psychologists to recommend interventions like group therapy and even the one-on-one psychotherapy relationship itself as forms of support, social support in people's lives, in patients' lives. By proving cause and effect, but proving cause and effect is difficult because we judge such claims by watching if the author ruled out alternative explanations, also known as extraneous variables in this new jargon. We follow those 3 rules for causation described in your textbook. Rule number 1, covariance. As A changes, B changes. Rule number 2, temporal precedence. Temporal means time. A comes first in time, then B. And number 3 is called internal validity, the 3rd rule for causation. This is the most important rule. If an author says A caused B, then there exist no possible alternative explanations for the change in B except A. This last rule is the most difficult for research studies to demonstrate, and it will teach you how research designers make decisions to help eliminate alternative explanations, again also known as extraneous variables. And finally, the 3rd takeaway from this chapter, we discuss measurement in psychological research and also ways that we measure, and measurement error, some of the challenges we have. One of the first challenges to conducting research in psychology that makes this a unique science, and really one of the first things that the healthy skeptic asks questions about, has to do with measurement of the abstract, non-tangible phenomena that we like to study in psychology, such as thoughts, opinions, and sometimes hidden emotions like stress, anxiety, depression. Measurement is the process of describing abstract, non-tangible concepts in terms of specific indicators by the assignment of numbers or other symbols to these indicators. So, measurement is a procedure where a researcher assigns numbers to quantify high, medium, low levels of, for example, stress, depression, self-esteem, whatever it may be. We all know, for example, that even something as abstract as intelligence, we can quantify, we can make numerical by the use of an intelligence test that produces an IQ score. So in this chapter, we introduce what are called operational definitions, the defining of variables in terms of the operations required to actually measure them. Now think of these as measurable representations of the abstract, non-tangible variables that we like to study in psychology. Psychology could not be a science without operational definitions that allow us to measure precisely the states of the variables in question: high, medium, and low levels of depression, of anxiety, of stress. Operational definitions also allow us to use quantitative measurement to apply numbers to that high, medium, and low, translating non-tangible variables, high, medium, into high, medium, and low numbers, which subsequently allow us to use statistics. Finally, know that there are three primary ways to measure any variable: behavioral measures, self-report measures like questionnaires or surveys, and physiological measures like heart rate and blood pressure. Be sure to read that last section of the lecture notes, by the way, about error in measurement and factors that can contribute to such inaccuracies. We want to decrease measurement error as much as possible. Too much measurement error, it decreases reliability, decreases validity, and that's not good. So in summary, the big takeaways from Chapter 3, called 3Claims, 4Validities, are these. Number one, that short article on scientific inference is a succinct review of all of our assumptions that we bring to reading research articles. Note that most of those concerns are resolved for us by peer review. Number two, big takeaway, to prove cause and effect in psychological research is very difficult and must meet specific standards. So this is so important because science moves forward by researchers discovering cause and effect relationships. And number three, measurement is the procedure where a researcher assigns numbers to quantify high, medium, and low levels of the kind of abstract, non-tangible phenomena that we like to study in psychology, such as thoughts, opinions, and sometimes hidden emotions like stress. Know that there are three primary ways to measure any variable, and that we try to minimize measurement error as much as possible. Those are the big takeaways, guys, from Chapter 3, called 3 Claims, 4 Validities. Thank you, everyone.